A.REI.3. This is Algebra, Reasoning with Equations and Inequalities, Part 3, Video 2, Solving Two-Step Equations. There are a few extra terms I'd like you to know on top of Video 1 that we had for solving one-step equations. I'd like you to pause the video and define like terms input and output. We have some two-step equations in this video. I'd like you to go through the steps with me on how to figure out what the x value is. Some of you could probably look at it right now and figure out what x is. What multiplied by 3, then added to 7 is equal to 19. We are going to continue to follow this process of inverse operations in order to get that x value. However, there are two different inverses that we have to be aware of, and the order does matter. So my rule of thumb is work your way farthest from the x variable until you get to the coefficient that's touching it. Now, as we get into video 3 and beyond, there are going to be some more steps involved, multi-step equations that have the distributive properties, some exponents, etc. But for right now, I'd just like you to know we only have a constant and a coefficient that is touching the x. So here is what we're doing. We're going to draw a wall. And working our way to the x, farthest away from, we're going to have to get rid of this constant 7 by doing the opposite of the sign that's in front of the 7. So the opposite of adding, as we learned in the last video, is subtracting. And we're going to take the right side to balance it out. We're going to subtract 7 from it also. All right, so that was step 1. Now the second step comes in here with the coefficient touching the x. So the opposite of multiplying by 3 is dividing by 3. So the 3's cancel. 3 divided by 3 is 1. X is equal to 4, and always take that 4, substitute it back into the original problem, and do the math. 3 times 4 is 12, added to 7 is 19, and it checks. 19 is correct. Okay, so x is equal to 4. Problem on the right made it a little bit more difficult by putting a coefficient of a fraction. Still working our way towards that coefficient, we have to undo this constant of -8 and be rid of it. So we're going to add 8 to both sides. All right, and remember that makes it 0. So how do we undo the fraction touching the variable? We learn that we are going to multiply by the reciprocal. And the reciprocal would be 6/5 on both sides. Oh, I could do better than that. So let's go 15/1 times that 6/5. All right, so our 5's cancel to 1's, the 6's cancel to 1's, and we have C equaling, all right, we can cancel here. 5 goes into both of them. 5 goes in 1 time, and 5 goes in 3 times. 3 multiplied by 6 is 18/1, which is simplified to 18. Go check that out. Problem on the left, I have some like terms. I see that I have some k variables, and both of them have a different coefficient touching them. So we are able to combine like terms. We'll do that first. So -5k's added to 13k's give me +8k's. And Let's get rid of the coefficient 8 by dividing. These 8 cancels. These 8s cancel, sorry. Negative 32 divided by 8 is negative 4. Go check that solution. And on the right, I threw in some decimals. I have a couple different ways that I can solve this. I think for this example, I can throw at you this idea of clearing the decimals. You can clear decimals and you can clear fractions to make it easier. It's not always easier depending on how the problem looks, and I think the next problem will give you an idea of what I'm talking about. But for this example, let's just clear the decimals. Finding the highest decimal place value across the equation, it appears as though the highest decimal in all of them is the 10th position. So all I have to do is multiply each of these terms by 10, and that will be rid of the decimal. Now, if there was a higher position in one of the numbers, then I would have a different process. But as of right now, they all have the 10th position being the highest. So multiplying this would get you negative 53 is equal to, there goes the decimal in 2 2/10 V, and multiply 8.6 by 10, you get 86. Now it didn't change the value of the equation, it just changed the look. It still means the same thing. We have an equivalent equation here. All right, same process as before. Let's work our way toward that V. We're going to undo this negative 86. Oops, sorry. Minus 86 plus 86, both sides. And we have 22V, those are gone, those turn into zeros, and a negative 53 and a positive 86. We have those alternating signs, so we're going to do the opposite and subtract those numbers. So let's come down here and subtract them out. No calculators, please. And we get some type of 33. Play the absolute value game because we're adding those up. And it looks like the 86 will win the absolute value game. So we're going to steal the sign of that 86 as positive. And last part, let's divide both sides by the coefficient of 22. So V is equal to, well, we could do some simplifying here. What goes into both of those? 11. 11 goes into 33 3 times and 2 times. So you have an improper fraction of 3 over 2, but if I were to simplify that, and let's put it back into decimal form, 3 divided by 2 is equal to 1.5 or 1 5/10. I like to put it back in the form of the way we started. So we have 1.5 equals V. Your turn. Pause the video, give this one a try. I will tell you, clearing the decimals can occur in this problem. However, the difficulty, because of this middle term, x or 1x over 2 5/10, would make it very, very difficult. It is possible. My suggestion is just to solve using your decimal operations of adding, et cetera, et cetera. Pause the video and try it out. All right, let's be rid of the 3 2/10 first, working our way towards this coefficient touching the x. So we have to look at the sign in front, and the sign in front is positive, so we undo that by subtracting. And we do that to both sides. 0. Left with our fraction. And if you want to grab some loose leaf and work it out up top here. So we have 1 4/10 equaling our fraction, and we have to either do your quick multiplication of your denominator times your whole number constant on the right side here, or you can multiply both sides by the reciprocal of 1 over 2 and 5/10, so that would be the reciprocal of 2 and 5/10 over 1. For time purposes, I'm going to just do the quick multiplication off to the side. Don't use a calculator, please. Little placeholder. If you remember, I like a smiley face. Add those up. And we have 2 decimal places in our original problem. There's 1, there's 2, so we take the decimal from the far end and move it over 2 times. We should have 3.5 or 3 5/10. So x is equal to 3 5/10. All right, last one is a little word problem here. They're talking about 2 of our new terms, the output and the input. So I want you to know that the input is noted as an x. That's what we put into the equation, and the y is what comes out of the equation, called the output. And as we move on this year, the x is also known as the domain, and the y is known as the range, and we'll get to that. So the problem states the output of a function is 7 more than 3 times the input, and then we have to find the input when the output is -8. So a lot of wording. Let's just go slowly through the wording together and just kind of write it out as we read it. So the output, we don't know what that is right now until we solve for it. So let's just set up an equation. The output of a function is, so the output, which is y, is means equal. So output is 7 more than 3 times the input. So it's 7 more than something. So let's start with that something. 3 times the input and 7 more than it. So there's your equation. Now they want you to solve when you know what the output is. So let's replace the output with that -8. So the output, -8, is 3 times a number increased by 7. And now you just solve it like a 2-step equation. So -8. Let me quickly do that here for you. Draw the wall. All right, what are you going to do? Subtract 7 from both sides. So x should be equal to -5. So when the output is -8, the input is -5. In your journals, define the given terms. I had some new terms on this video for you. Write a few sentences on what you think you learned from watching this. And please, if you have any questions on any of the problems or anything that we're doing in class, never hesitate to ask myself or your peers, and we'll knock out these standards for you.